Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the sampling distributions question. You can simply follow my YouTube channel where you can find the playlist of the IIT Jam and you can see the various lectures related to the mathematics and statistics with the help of the shortcut tricks explained. Also there is a playlist of the gate statistics and you can see the complete PY question series is available in this playlist. If you are new to my YouTube videos, you can simply subscribe my YouTube channel and you can join with me through my WhatsApp group of the IIT Jam Statistics and Mathematics. Okay, now look at that. What is given to you? X and Y are following normal distribution 0, 1. Always remember, whenever you are seeing the normal distribution and the question is asking about the square, your target is to convert into the chi-square. What is the chi-square is? If I say x minus mu whole square divided by this, it is my chi-square of 1 degree of freedom. Now you can see, what is the x minus y? It again follows the normal distribution. Mean is 0, variance is 2. X plus y again follows the normal distribution, mean and 2 of this. Now I can written here x minus y minus of mu, mean is my again 0, divided by variance. Fine, divided by again, so it means this one follows my chi-square distribution 1. Clear? Similarly, if you look about this denominator part, x plus y whole square divided by 2 also follows my chi-square distribution 1. Now the ratio of the two chi-square distribution, fine. So I can return this is, I call this is my say y, oh sorry, y is already given. If I call this is my p and this is my q, so then p divided by the degree of freedom divided by q divided by the degree of freedom will follows the f distribution with the 1, 1 is the right answer. Look at this another one. What is the shortcut tricks for you? Whenever you have the x which follows the uniform distribution, then ln of x minus ln of x will follow the exponential distribution 1. So same I can use here. You can see u is follows my here, so ln of u1 minus of ln u1 will follows the exponential distribution 1. Also we can see u1 minus u2 also follows the uniform distribution, so then minus 1 minus u2 also follows the exponential distribution 1. Fine. Now because I need a ratio, so if x follows my gamma distribution with the parameter this, y follows the gamma distribution with the parameter beta comma this, then x over x plus y will follows the beta distribution with the parameter alpha comma beta. Make sure these parameters should be same. So can you write this in terms of the gamma? I can written this is 1, 1. This is I can also written as a 1, 1. So if I take this is my x and this is my y, so if I add them it becomes my this quantity, so this becomes follows my beta distribution of 1, 1. Then what is the variance of beta distribution? So if x follows my beta distribution a comma b, then the variance of this will be ab divided by a plus b whole square, a plus b plus 1. So if I substitute here, the variance of y 1 plus 1 whole square is a 4 into 1 plus 1 plus 3, so 1 over 12 is my right answer of this problem. So this is the way you can simply remember this shortcut tricks and solve. Okay, what is given to you? X follows my f distribution of m comma 1. 1 over x will follows the f distribution of n comma m. Fine. Then what is the expected value of the f distribution? N over n minus 2. Similarly again it's expected, so what is that? This will be m over m minus 2. Then your target is to multiply them. So if you multiply them, this m into n over m minus 2 is the right answer. This is the always remember the tips which is very easy for you. Okay, look at this another one. Which distribution is here? Again you can see it is my gamma distribution with the parameter alpha comma lambda. Fine. Then what is the expected value of this? It's a gamma distribution, so it is a gamma alpha over this is my expected value, and clearly say both are my greater than 0, so yes, it exists. What is the variance of the axis? It is alpha over lambda square. Again both are my greater than 0, yes, it exists. Fine. Now once you know x is my gamma distribution of alpha comma 1 over x will again follows the gamma distribution with parameter here. Fine. You have to reverse them and this. Then what is the expected value of this? Again you can use about here. First divided by this number. So is it existence for all alpha? No. It is not existence when alpha is equal to 1. So that means he said existence. So which of the following is not true? So this option, this is here, and because this is a transformation, is S is correct option. So this is my correct option, this is correct option, this is correct option. Only unknown is my C is the right answer of the problem. Okay, what is given to you? x1 and x2 follows normal distribution with the 0, 1. Oh, this kind of the question will very important. Fine. Every time in each year this question will be asked in the examination. Now you can see what I gave you the tips is whenever you will see the normal distribution and square, it will always follow the chi-square. Fine. So what is that? What is the x1 square, or I can write x1 minus mean divided by variance. So that means x1 square will follow the chi-square distribution with a 1 degree of freedom. x2 square will follow the chi-square distribution with the 2 degree of freedom. Fine. Now once you know the 2 degree, now I need a sum of them. So what is the meaning of that? x1 square plus x2 square will follow the chi-square distribution of this. Now I can write this in terms of the gamma function. Fine. Always remember how you can write the gamma function. If you have the chi-square distribution of the 2n, it is always the gamma function of n comma 1 over 2. So you can see n is my 1 and here. Fine. Then your target, if I call this is my y, then your target is to find the probability of y is less than equal to 2. Fine. One more I will give you the tips. That is the most important tips when you solve this integration, because for that you need a gamma distribution PDF. So if you never know about that, remember, if x follows my gamma distribution of say 2 comma a, then lambda times x will follows the gamma distribution of 2 comma a over lambda. Fine. Now whenever you have the gamma distribution and this number is my non 1, then your target is to make this number to be 1. So how I can make them? I can use this parameter. What should I be multiply here so that this becomes a 1? I can say this number. Fine. Or you can simply say instead of the 2, whatever the number is there, if it is my x, it is my x. So what is that? This will be my, can you find this number? It will be 1 comma of 1. Fine. Is it correct option? Now once you know this is my, okay, now I can make them into the half of the y. So if I divide it by half on the both side, it is less than equal to 1. Fine. So that means this is the gamma distribution of 1 comma 1. So you know what is the gamma distribution of 1 comma 1? It is basically exponential distribution of 1. Fine. So basically this is exponential distribution of less than 1. So that is my CDF, 1 minus lambda into x. So 1 minus is the right answer of the problem, because we all know once you have the exponential distribution, the CDF is 1 minus e raised to power lambda x. In this particular example, this is my x and this is my lambda. So you can see is the right answer. Again you can see x follows my gamma distribution of 2 comma half, and your target is to find the x greater than 4. try to make this as a 1. So I can half of x will follows the gamma distribution of 2 comma 1. Fine. Now I can make them to be the half. So I call this is my y. So y half is greater than of 2. Now what is the gamma distribution of 2 comma 1? We all know it is a y e raised to power minus y. Fine. Now I can see it's a 2 to infinity y e raised to power minus y. So what is the integration of this? Minus y plus 1 e raised to power minus y. So when you substitute infinity, it's a 0, minus minus plus 3 e raised to power minus 2 is the right answer of the problem. And you can see within the 2-3 lines you can get your answer. Make sure your target is to make this number to be 1. And you can see it's a 2010, it's a 2010, both questions asked here. Now it's a 2011, xi's are my IID, xi's are my IID, and it follows the exponential distribution here. Then what is x1 plus x2? It follows the gamma distribution with the sizes 2 comma. Fine. What is that tips for you? If xi's follows the exponential distribution with the parameter lambda, and summation of xi's will follows the gamma distribution with the parameter n comma lambda. Fine. So if I call this is my y, so my target is to find probability of y is greater than 1. I again make them to be the 1. So y follows the gamma distribution of 2 comma 3. So how you can make them to be the 1? If I divide it by 3, fine, then it will be 2 comma 1. So again I can make them to be y over 3 is greater than of 1 over 3. Fine. Then how you can make them? This is exponential distribution with the parameter 3, so I can make them to be here. So what is that? If I call this is again as say p, so that means probability of, so I call as a q is greater than of 1 over 3. So what is the PDF of this? As I told you in my previous, is a y into e raised to power minus y. Fine. Sorry, I have to multiply by 3. Sorry. This is probability of y is greater than 1. Y follows gamma distribution of 2 comma 3. Remember what is the tips is? You have to multiply them. It is divided by here. So I can say 3y will follows the gamma distribution of 2 comma 1. So I can try to make them as a 3y. 3y is greater than 3. So I call this is say q. So that means probability of q is greater than 3. So it's 3 to infinity. PDF of this is y into e raised to power minus y. Fine. And you can remember this, the integration of this is y plus 1 e raised to power minus y. So when you substitute infinity is a 0, 4 e raised to power minus 3 is the right answer. Again you can see that. Now you can see in the consecutive years 2010, 2011 and 2016 the same kind of the question asked about. Why it's the same kind? Because whenever it's a normal, you can write in the chi-square. What is the chi? X square over 1. This follows my chi-square distribution 1. Similarly y square, y is a 0 divided by the variance. Again it follows my chi-square distribution 1. Then x square plus y square will follows my chi-square distribution 2. Then I can write the chi-square distribution in terms of the gamma. If it is a 2n, then it is gamma of n comma half. So this I can written as gamma, n is my 1 of half. So I call this is my say q. Fine. So q follows my gamma distribution of 1 comma half. And your target is to find probability of 0 less than 4. So I can again make them to be the 1. I can multiply by half. It follows the gamma distribution of 1 comma 1. 1 comma 1 is basically a exponential distribution 1. So I can make them to be the half. So I can divide it by half. This is my 2. Now it follows the gamma distribution, it follows the exponential distribution. So f of 0 minus here. What is the CDF of the exponential distribution? E raised to power minus lambda x. So I can substitute here 1 minus lambda is my 2, lambda is my 1, x is my 2. 1 minus lambda is my 1, exponential x is my 0. So 1 minus e raised to power minus 2, this is my 0. So 1 minus e raised to power minus 2 is the right answer of this problem. You can see that you always try to convert into the gamma 1. Now you can again say it's a 2020. The same question will be asked here. Fine. So what is that Z1 square? It follows my chi-square distribution 1. Z2 square. It follows my chi-square distribution 2. The sum of them will follow chi-square distribution 2. I can return this is gamma of 1 comma 1 over 2. Fine. This is 1 comma 1 over 2. Now I can make them to be the 1. So it's a half of this will follow the gamma distribution 1 comma 1. That is my exponential distribution 1. So I can make them to be the half. So it is a half of y is greater than 2. So now I can return this is in the form of the CDF half of 2. So what is the CDF is 1 minus lambda is my 1. This is my lambda x into my 2. So it is e raised to power minus 2. A is the right answer. You can see the same concept asked in the each years. That's why the PY question solving before the examination is a very, very important. Okay. Again, it is a, okay, what is given to you? X1 will follow the chi-square distribution with the 2 degree of freedom. X2 will follow the chi-square distribution with the 2 degree of freedom. Then, what is the distribution of the W? Sum of them will follow the chi-square 4 degree of freedom. So I can write this again in terms of the gamma. So that is 2 comma 1 over 2. Why? Because I can compare them with the help of here. Fine. So n will be my, you can see n is my 2. Clear? Now what is given to you? Find the probability of W which is greater than of expected value of y, expected value of W. So what is the mean of the gamma distribution? So you can see what I told you in the gamma distribution. This is alpha over lambda. That's a ratio of them. So you can see what is the mean of this? 2 over 1 over 2. That means 4. So your target is to write this number. Now I can make them to be the 1. So half of W will follow the gamma distribution of 2 comma 1. So I can make them to be the half. This is my 2. So now it's a CDF of 2 gamma of 2. Sorry, it's not a CDF because it is not an exponential. So what is the PDF of this is y e raised to power minus y. So 2 to infinity y e raised to power minus y. What is the integration of this is y plus 1 minus 1, 2 to infinity. So 0, it is my plus 3 e raised to power minus 2 is the right answer. So 3 divided by e square. You can use the calculator and get your answer. Okay. Again you can see about here xi's are my normal distribution with a mean 0. Or variance is not given to you. I can assume take theta is 1. Fine, because answer is not dependent on the theta. So then this numerator part x1 square plus x2 square will follow the chi-square distribution of 2, because each of the chi-square each of the xi square will follow my chi-square distribution 1. Now similarly okay, first of all look at that whether the independent is given to you in the question. It is not given to you. Fine. So once it is not the independent, then what you can say, this factor already I have computed. So x3 square plus x7 square again follows the chi-square distribution. How many numbers are there? 3, 4, 5, 6, 7. So it is a 5 degree of freedom. Now you can see independent is not given to you. So if I call this is my P, this is my Q. Fine. So what is that? P over P plus Q. Fine. P over P plus Q. So what is that? If it is not independent, then it is follows the beta distribution with the parameter degree of freedom of the first case. That is, I can say this is n1 over 2 and n2 over 2. So what is that? So that means this ratio K will follows my beta distribution of n1. So what is the degree of freedom is 2 over 2 and 5 over 2. So that means it follows my beta distribution of 1 comma 5 by 2. Fine. So now if you look about the option, which are the following? Okay, first one is the obvious one, is the correct. K and this denominators are independent. Now this one, F distribution. F distribution is applicable only when the ratio are my independent. Fine. Are they independent? It is given to you? No, because you can see also x1 both are common and they are not given as independent. So definitely this is not F distribution. So this option is cancel out. This option is cancel out. Now how you can find the expected value of x square? So that means, so once is a beta distribution, what is the expected value of here? So if I call beta distribution of a comma b, then your this will be a plus 1 divided by a plus b and a plus b plus 1. So if I substitute here, a is my 1 into 2, 5 over 2, a plus b will be 7 by 2 and 7 by 2 plus 1 is a 9 over 2. So it's a 8 over 63. So yes, this is the correct option. So only this is B is my correct answer. Look at the word independent is the most important. If it is the independent, then you can say it's a F distribution. But right now it's not a F distribution. It's a beta distribution. Okay, look at this another one. Okay, that's kind is very important. Always remember, if F follows my m comma n, then as I told you in the earlier example, 1 over x will follows n comma m. Fine. Now if you look about this x and y, what does it means? Y is nothing but 1 over x because it has the same. Now I can write this. I can substitute x is my 1 over y, greater than 4 is 0.01. What is the value of the y? Y is less than of 1 by 4 is my 0.01. Now you can compare them. K will be 1 by 4. Fine. If you compare this equation with here, and you can see within the 2 lines you can get your answer. Again you can see it's a MS 2012 and the same kind of the question is asked in the MS 2020 as well. So again you can see from here. So U is nothing but 1 over V. Fine. If I substitute here, what is my V? V is less than of 1.69 is 0.05. Then this is greater than. So I can convert into the greater than sign. I can change into this is less than of C is my 0.05. Fine. Now if you compare them, C will be 1 over 3.69 is the right answer of the problem. And you can see how many seconds you are needed to solve the problem. You are just needed to solve this within the 10 to 15 seconds. And that much second you are needed to comment and like on my video as well. Again you can see that it was in the 2012, it was in the 2020, and now the same kind of the question is asked in the 2023. So what is you conclude? Y is nothing but 1 over x. I can substitute here. So 1 over y is less than equal to 2 is my 216 over 343. So I can find the value of y. So y is greater than or equal to 1 over 2, which is 216 over 343. Now I need a less than of this. So how I found the value of less than? I can subtract them to be the 1 minus 216 over 343. So what is that? It's a 127 over 343. Fine. Now alpha, this is my alpha. then your target is to 686. If you multiply by 686, so 343 will be cancelled out into 127. So 254 is the right answer. Now look at this another one. Okay, so firstly I will give you the tips. So as I told you, when the F distribution will be appears, when it is a ratio of the chi-squared distribution. Fine. When the T distribution will be appears, when it is a normal distribution divided by chi-square distribution and degree of freedom, then it is my T distribution, and make sure both the variables are my independent. Now look at that. Your target is to find the distribution of W. So how you can write the distribution of W? It's a very simple. Firstly, you can see about that. We always remember this over here. It follows chi-square distribution with the degree of freedom n minus 1. Always remember. Fine. So now if I put up as a square, this is my n minus 1. It's a 99. It's n minus 1. So it is a 98. Sigma square is my 4 over s square. It follows my chi-square distribution 98. Fine. Now you can see what is that? Denominator is a chi-square, but numerator is not a square. So definitely F distribution will not be happen. Fine. Now what is that? X of 100. X of 100 will follows my normal distribution 2, 4. So x of 100 minus of 2 divided by 4 will follows the normal distribution. Fine. So if I divided this quantity by 4, fine, and this denominator quantity is my, again if I divide it by here, we can see the numerator is my normal, denominator is my chi-square. Fine. So definitely it will be my T square. Now the only question arises is, what is the degree of freedom? The degree of freedom will be here. This is 98. So this option is cancelled. This one is the correct option of this example. Fine. Or moreover, you can make them also if you want, like this W I can written as x bar minus 2 divided by 4, and I can multiply by 4. This S I can written as square root of 98 s square by 4, like of this, divided by degree of freedom, that is 98, and you can see this 4 I can adjust it as here. Fine. It will be cancelled out. Now you can see it's a complete, that this is my normal, this is my chi-square, degree of freedom will be 98. Fine. So it is my C is the right. Okay, Xi's will follows my uniform distribution of minus 5, 5. Your target is to write in the chi-square. What is the mode of X? Mode of X will follows the uniform distribution of 0, 5. Fine. Then mode of Xi divided by 5 will follows the uniform distribution of 0, 1. Now what I gave you the earlier tips, if this one minus ln of x will follows exponential distribution, so it means minus ln of xi divided by 5 will follows the exponential distribution of 1. Now you can put minus of 2 times. Fine. Now if I take the summation of this, minus of 2 outside, summation of xi by 5, so summation will follows the gamma distribution with the parameter 10, 1. Fine. Now your target is to write this quantity in the you can convert the gamma function into the, sorry, it is a 2, it's a single x, this one. Fine. It is not a 2, it is not a 2. Fine. So I can make them as summation of ln xi over 5 will follows the gamma distribution with the, what is the n is 10. So 10, 1. Now you need a 2. So what is the meaning of that? If I say y will follows gamma distribution of 10, 1, then what is the meaning of that? 2y. 2y will follows the chi-square distribution of, what is the double of this degree. Fine, the double of this degree. So I can say twice of this will follow chi-square of double of this degree. So the chi-square of 20 is the right answer of the problem. Okay, now you can see it's a square. So definitely we are working on the chi-square. Firstly, I can find the y1 distribution. Sum xi's will follow the normal distribution of 3, 12. What is the x bar? Will follow the normal distribution sigma square by n. So it's a normal distribution. Mean is 3, sigma is my 12, n is my 6. That means normal 3, 2. What is my y2? Y2 is again it's the average. Normal distribution is 3, 12. What is the n? You can count them 7, 8, 9, 10. That's a 4. So it is n of 3, 3. Now, what is the distribution of the y1 minus y2? Again, it follows the normal distribution. The mean is the subtraction of the mean. Variance will be 2 plus 3, 5. Because it will be variance of y1, variance of y2. Variance of y1 is 2, variance of y is here. Fine. Now, I can make them as a square. Mean is 0. So, divided by variance, it will follow the chi-square distribution 1. So, now you can see what is the alpha. Always remember, whenever you have the normal distribution and the square present, always write in the form of chi-square. This is the same question. Fine. What is that? X follows my uniform distribution of 0, 1. What does it mean? Minus of log x will follows exponential distribution of 1. Now minus of 2. So minus of 2 means I can put up as sum of the 2 minus log x minus log x. It will follows gamma distribution of 2, 1. So once I call this is my y. So y follows the gamma distribution of 2, 1. What is the expected value of the y? Over this is the right answer. Fine. You can see it's a very, very simple. Just try to understand the concept of this, my shortcut tricks. Okay, it's a chi-square distribution. Now if you look about the statement, it's a GATE 2019 question here. If you look about the statement, they are talking about the degree of freedom. M and N are the degree of freedom and the probability. Always remember, whenever the degree of freedom is greater than of the n, then the corresponding probability of the variable is greater than of the corresponding probability of this. Now look at that. Whenever m is less than of the n, what is the m corresponding variable is x. So x is greater than a is less than of y greater than a. Is it true? Wrong. Whenever m is greater than n, the corresponding probability is also greater than of this. Yes. Equality only when it is equality. None of this is the wrong. So always remember this shortcut tricks. Now you can see it's a GATE 2019 question, and you can see this question is asked in the same question is asked in the MS 2021. So if you are the student of the IIT JAM, I always advise you can practice the GATE PY questions as well. And if you are the student of the GATE, you can practice the IIT JAM as well. Now you can see 6 is a degree of freedom which is greater than of 3. Fine. So what is the meaning of that? The corresponding variable x is greater than of corresponding variable of the y. Make sure it has the same parameter. If I is a, it must be a. So you can see x is greater than. Fine. It is a less than sign. Wrong. It's a less than sign. Wrong. It's a greater than sign, but it is my less than sign. Make sure it must be of the greater than sign. So only a is my right answer. Okay, again you can see it's my normal distribution and it's a square. So x1 square, xi square, because it's a 0 and a 1, is follows my chi-square with the degree freedom 1. Then what is the capital T? All are my addition. So it follows my chi-square distribution with degree of freedom 10. Now, can you write this in terms of the gamma distribution? So again, the same concept I have used. This will follows the gamma distribution n comma half. So what is the n? 5 comma half. So once the t follows the gamma distribution, what is the 1 over t? It follows half comma n minus 5 minus 1. As I told you, if this follows the gamma distribution here, then 1 over t will follows the gamma distribution again b a minus 1. So that means it is half comma 4. So 1 over t. So what is the mean of the gamma distribution? What is the mean of the gamma distribution? A over b. So I can write again for you what is the mean of this. This is my tips for you. Okay, so this is a over b. Fine. So it is 1 over 8 is the right answer of this problem. You can write into the decimal places as it. Always remember, student, whenever you have the chi-square, you can use this shortcut tricks and convert into the gamma distribution. Okay, now again it's a s square. Fine. So now it's a 10, it's n minus 1. So I can written as n minus 1 sigma square s square will follows my chi-square distribution of n minus 1. So n will be 10 minus 1 9, sigma square will be my 2, s square will follows the chi-square distribution 9. Then your target is to find the variance. So I can take the variance on the both side. 81 over 4 variance of s square. So remember again, another tips for you. If x follows my chi-square distribution with the degree of freedom n, then the expected value will be my n, variance of the x will be my 2n. Fine. Now we are talking about the variance, it is my 18. So can you find the variance of s square, which we needed? 18 into 4 over 81, 9992, 8 over 9 is the right answer. You can see how many seconds you are needed to solve the problem. Just 15 seconds you are needed if you remember my shortcut tricks, or you can do more practice on that. Okay, again xi's are my uniform distribution of 0 comma 1. So what does that mean? I need a ln of x. So minus ln of xi's will follow the exponential distribution of 1. Clear? Now it's a square. Firstly I can see, I can return this numerator part is log of n1, ln of x1, ln of x2 plus ln of x3 of whole square. Fine. So if I can call this is my y, then your target is to find the expected value of y square. Clear? Now how you can find the value of, how you can find this ratio? If I say how you can find that? Okay, ln of this, the sum, okay, then summation of ln of xi, because it's exponential distribution, the sum will follow the gamma distribution with the how many? 3 comma 1. Fine. So the denominator is a gamma distribution. Fine. But the numerator is my exponential, so this is my gamma. So the ratio of the two gamma distribution, we can't say anything. Fine. So what I can do is, okay, got it. Remember, as I told you earlier, if x follows my gamma distribution with the parameter alpha comma say a, y follows my gamma distribution with the parameter beta comma a, the same parameter will be here, then the x over x plus y will follows beta distribution with the parameter alpha comma beta. Fine. Now you can see it's a x. I can make this as a separate. So what is the distribution of this? ln 2 plus, so I can add only 2 times. So ln 2 plus ln x3. This will follows the gamma distribution of 2 comma 1. And now you can see this parameter is same. So I can apply this one. So I called this y will follows beta distribution with the parameter of 1 comma 2. Then your target is to find the value of this will be, if I call, what is that, if I call this is AB, so AB over A plus B whole square into A plus B plus 1. So if I substitute here, AB is my 2, 2 plus 1, 3 square is 9, 2 plus 1, 3 plus 1 is 4. So 1 over 18 is the 1 over 18. So where is my mistake is? Where is my, is it calculation is okay? So A into B 2, 2 plus 1, 3, 3 square is my 9, and 2 plus 2 is 4. So it is fine. This is my 2, 1 over 18. So why it is not be happened? It is 1 over 18. 1 over 18 is not there. So can you identify the error? Xi follows this one, ln of this. Oh, got it, got it. This is not the E of y square. This is the variance. This is the variance. Sorry. This is the variance. Okay. Okay. This, if it is a variance, I can found the mean also. What is the mean of this distribution? That it means A over A plus B. So it is 1 over 3. So once you got as 1 over 18 is my variance. Fine, this is 1 over 18 is my variance. So can you find the E of y square from here? So yes, you can find it 1 over 18 minus minus plus 1 over 9. So it will be 3 over 18. So 1 over 6 is the right answer. Okay, look at this another one. Xi's are independent and normal distribution. So Xi's follows my normal distribution of 0 comma 2. Then what is my x1 minus square? This will follows my chi-square distribution 1. Fine. Then similarly, so xi square divided by 2 will follows my chi-square distribution 1. Now if they are independent, it is given to you as independent. Now I can write this quantity as this one, x1 square divided by 2 multiply by 2, so that it becomes a chi-square. What is the degree of freedom of this? You can see it's a 10 degree of freedom. Fine, it's a chi-square with a 10 degree of freedom, but it is a divided by 2. So, or instead of that, I can say I can divide the numerator and denominator by 2. Fine. So it will be x1 square up to x10 square divided by 2. So that is, this one is my chi-square distribution 1. This one is chi-square distribution 10. Fine. Now you can see, is it independent? Yes, they are independent. So the ratio of the two chi-square distribution will be F distribution. Fine, F of 1 comma 10. Now your target is to find the expected value of the F distribution. So what is the expected value of the, what is the F distribution? What is the expected value of the F distribution? So do you remember what is the mean? If F has a m comma n, then what is the expected value of this? Expected value of this will be n over n minus 2. So it will be 10 over 10 minus 2, that is 8. So 5 over 4, 1.25 is the right answer of this problem. Fine. So this is the way you can easily got this answer as here. So n over n minus 2 is the degree of freedom of this problem. Okay, so look at this another one. So let me, is it correct? Because it's a divided by 2. Fine, chali, anyhow. Okay, the same question I already explained in the earlier. Fine, because you can see it is independent is not given. So I think I already explained that this is, and these are the correct option. Okay, which of the followings are my independent random variable? Okay, just wait, I am just confusing about this question again, because here is x1 and this is also x1, so they, although they are independent, but it is not a F distribution because they are not independent. X1 is here, x1 is here. So just let me re-evaluate it. So what is given to you? x1 square plus x of 10 square. So yes, it's, if you divide it by 2, it's a chi-square. Fine. So this is the chi-square, this is chi-square, but they are not independent. So what I can do is x1 square over 2 I can separate, and the rest of them I can separate as here. Fine. Now it's a chi-square, it's a chi-square, and it's a chi-square. So what does it mean? But they are not, this pair are not independent. The ratio are not independent. So I can say this is my beta distribution with the parameter half comma is a 10 by 2 is a 5. Then once you know it's a beta distribution, then we can find the mean of this. So mean will be half over 5 minus 1. So that means 1 over 8. Yes, 1 over 8 will be the right answer of this problem, instead of, because it's not a F distribution, because of this x1, both are the same. Which of the following is my independent pair? So clearly say x2 and x2 are there, so it is not independent. x1 and x1 are there, not independent. None of them is common, fine. x2 and x2 are there, it is not independent. Okay, so your target, I can write this one is summation xi square divided by m of yj square. So clearly say the denominator is my square, so that means it will be look like say chi-square, and this is my whole square. Fine. And but this is okay. What is xi? Xi follows my normal distribution. Some of them will follow the normal distribution 0 and n. Then I can convert into the z, xi minus 0 over n. This will be my over this. This is my z distribution. Fine. So if you look about, if I put up a square, that means this over n, it follows my chi-square distribution with the degree of freedom n. Sorry, m. It will be my m. It will be my m. Fine. So then similarly yj square will again, what is the yj square? Yj square will follows my chi-square distribution with the degree of freedom 1. If you put up this summation of the yj square, j varies from n, it follows the chi-square of n. Fine. So once you can return this is chi-square of n, what does it mean? If you take the ratio, now it's both are independent. Fine. So ratio of the both chi-square, it will be F distribution with the degree of freedom, m degree of freedom of the x, and here is the correct answer. T distribution only when the numerator is a z and denominator will be the square root of the chi-square. Okay, look at this one. Now you can see the denominator is my root of this, and the numerator is only single one. So if xi follows the normal distribution, the difference of them will also follow the normal distribution. Fine. This one is a square, it follows the chi-square distribution. It also follows the chi-square distribution. So what is that? Normal over chi-square will follow the t distribution. So all are my t distribution. Now what is the degree of freedom? Degree of freedom of this. What is the degree of freedom of the first part is n minus 1. What is the degree of freedom of this one is? If you subtract them, it will be m minus 3. Fine. You can see n plus m minus 2 and n plus 1. It is, so what is the total degree of freedom is? N plus m minus 4. So the right answer is n plus m minus 4. This one. So this option cancel out. Now out of these two options, how you can check about that? Again, a very simple. What is the xn plus 1 minus of this? It follows the normal distribution with a mean 0. Variance will be 2 sigma square. And from here, again you can see n minus 1 sigma square of s square will follow the chi-square degree of here. Fine. Now I prove that the degree of freedom will be here. So this number is basically degree of freedom. So I can say n plus m minus 4. Sigma square will be my sigma square. So you can see n plus m minus 4 must be there. N plus m minus 4 must be there. So this option is cancelled. This is the right answer. Because I can see s square will be sigma square over n plus m minus 4. So if I put up as the square root, it must be here. And this 2 will be from this one. Okay, same case from here. What is that distribution of the x bar? Normal distribution with the mean mu. Variance is sigma square by 3. Y bar is follows the normal distribution with the mean mu sigma square by 4. Then x bar minus y bar will follows the normal distribution this, and you can add them. Fine. And this one, this is just like say s square. So the degree of freedom of this will be 2. It is a 4, it's a 3. So degree of freedom will be my 5. So this mu is my 5. Fine. So this is my 5. Then now again it's the same. So it's a 5 over sigma square into s square. It follows my chi-square distribution of 5. So s square will be sigma square over 5. Fine. This will be here in the denominator. So I can write this is my sigma square over 5. This is my chi-square, and in this part is 7 by, so it is divided by 7 over 12. Fine. Sigma will be here. So that sigma will be common out. So root 5 I can written in the upper numerator. Root 5 over root 7 into root 12. So what is the factor of this? It's a 2 root 3 root 15 over root 7. So if you compare them, k will be my 2. So 5 minus 2, 3 is the right answer. Okay, xi follows this one. Which of the following will give you approximate of this? Oh, very simple. What is that? Can you find the mean of this? What is the mean of this? Each has a mean 1, so it's a 0. Fine. So all have the mean 0. Can you find the variance of this? Because they are the IID, so the variance of this is my 1 plus 1, 2. So that means this quantity will follows my normal distribution of 0, 2, because it's a IID. Okay, XR are IID distributions and the mean of this. That's very simple, because each of the xi's are my IID. That means each behaviors are my same. So if I replace them to be here, is my say 2 xi's divided by 3 xi's. It will be E of 2 over 3. So E of 2 over 3 is my simple 2 over 3 is the right answer. Okay, again you can see it's a very simple. You can see about here x1 square, it follows my chi-square distribution with a 1, and you can see all are my independent because nothing is given to be here, and the denominator will be chi-square. How many factors are there? 4. So therefore I can written W as chi1 chi-square with a 1 degree of freedom and chi-square with the 4 degree of freedom. So I have to multiply by 4 also. Fine. Or you can see 4W will follows my F distribution with the 1, 4. Then can you find the expected value? Expected value of W is, what is the expected value of F distribution? Expected value of the F distribution is M over N minus 2. So that is my 2. So expected value of W will be 2 divided by 4. So 1 over 2 is the right answer of this problem. Okay, look at this another one. Again you can see this part is my square root, so this part will be my t, is my chi-square. Numerator part is x square minus something, it's a normal. And you can see x and yi my independent. So the ratio of them will follow the t distribution. What is the degree of freedom? So what is the degree of freedom will be here is m minus 1, because this is just like say s square. So m minus 1 is the degree of freedom. So t of m minus 1 is the right answer. So is first of all f will be cancelled, f will be cancelled. Fine. Then what is the degree of freedom of this is n. Denominator is my m, so it is cancelled out. So only m will be right answer of this problem. Okay, look at this one. Is it a 2? First of all, it's independent. Yes, they are independent. It's a normal distribution. And what is the degree of freedom of this? Chi x2 square follows the chi-square distribution 1. x3 square will follow the chi-square distribution 1. The sum of them will follow the chi-square degree 2. Again you can see this is my normal. This mode quantity I can return, this is the square of this. So yes, what is the degree of freedom of this? 1 plus 1, 2. Degree of freedom is my 2, but he said 1. So this option is cancelled. They are my independent. Fine. x1 minus x2 follows my normal distribution of 0, 1. x1 plus x2 will follows the normal distribution of 0, 2, and you can see the square of them will follow the chi-square degree 1, 1. Here it is my x1 square plus x2 square plus x3 square. What is that? It follows the chi-square degree of 3, but he said 2 is the wrong answer. Sorry, this option it's not a square. It is not a square. It means what is my x2 plus x3? It follows the normal distribution with here. Then this square will follows chi-square distribution 1, because it's a single quantity. If I call this is my y, then this y square of this will follows my chi-square degree 1. Yes, this is the right answer. Okay, look at this another one. Okay, is a ordered statistics is given to you, then which of the following statement is not true? X follows my uniform distribution of this one. So, okay, I will tell you the general rule. X of ordered statistics will follows the beta distribution with the parameter r, n minus r plus 1. So that's over. First option is x9. x9 will follows the beta distribution of 9. N will be my 9, so 9 is 1. Fine. Then if x follows my beta distribution, then x over 1 minus x will also follows my beta distribution of 2. Fine. Then what is the mean of this? What is the mean of the beta distribution? That is my a over b minus. Always remember, if x follows my beta distribution of a comma b, then the mean of this is a over b minus 1. So that will goes to the infinity. He said finite, so this is not true. What is the e of x5? So firstly, what is x5? So 5, beta distribution of 5 comma 9 minus 5 plus 1, so 5. So clearly say you can see it's a symmetric. Fine. So once both are the symmetric, so it means the expected value will be 0.5. And it's a beta 1 distribution, so the mean will be m over m plus n. That means 5 over 5 plus 5. 5 over 5 plus 5, that is 0.5. Because it is a symmetric, so the median is also 0.5, mode is also 0. Because of the symmetric, mean, mode, median are same. But we need a not true. So only A is my right answer of the problem. Okay, look at this another one. This is my chi-square. This one is also chi-square. Why? Because x1, x2 plus x3 will follow the normal distribution of this, and if you put them as a square, it will follows my chi-square degree 1, and both are my independent. So this u will follows the f distribution of 1 comma 1. Is it a v? V also. X2 minus X3 will follows the normal distribution of 0, 2. The square of them will follows my chi-square distribution 1, and you can see they are not independent. Now, is it independent? Yes, they are independent because it's a separate quantity. This has the degree of freedom 1, this has the degree of freedom 1. When you add them, it will have a chi-square 2 degree of freedom. The numerator has the chi-square 1 degree of freedom, so the ratio will be f1, 2 degree of freedom. Fine. Now clearly say, oh, both are my independent because none of them is common. And once you take v into 1 plus u, is it a 3 degree of freedom? No, because it's a product of them. So the degree of freedom will be remain the 2, but he said 3. So A and C are my right answer. Okay, look at this another one. F, y follows my F distribution 4, 2. Then there are two methods. Firstly, you can write the PDF of the, or you can remember the PDF of the F distribution. Otherwise, what is the definition of the F distribution? If I say this is x divided by 4, sorry, x chi-square, sorry, I can written like here, x divided by 4 and say q divided by 2, where x follows my chi-square distribution with the 4 degree of freedom, q follows my chi-square degree of 2 degree of freedom. Fine. And you can see both are my independent. So then what is the distribution of the x comma q, which follows my beta 2 distribution of 4 by 2, 2 by 2, that means beta 2 distribution of 2 comma 1. So this is my y. So your target is to firstly find y which is less than of 2. So that means it's from 0 to 2. What is the PDF of the 2 beta 2 distribution? That is my x over 1 plus x cube. So I can written here is x over this value. Fine. So how I can integrate them? I can add plus 1 and minus 1. So this value becomes 1 plus x whole square minus 1 plus x cube. So what is the integration of this first part? Minus 1 plus x, and it will be 1 plus 2 times 1 plus x square. So I can substitute 0 to 2. Once you can substitute here, you can see its answer is minus 1 over 3, minus 1 over 3 plus is a 2 plus 3, 2 plus 1, 3, 9, it's a 1 over 18, minus, if you substitute 0, it's minus 1 plus 1 over 2. So I can written as 18, 6. So minus 5 over 18, it's a minus half plus 1 over 2. So that means 9 over 18. So 4 over 18, 2 over 9 is the right answer of this problem. Is it fine? But 2 over 9 is none of the right answer. So it means I have do some calculation mistake. Fine. Let me, it's a minus 1 over 1 plus x. Fine. And it's a 1 over 1 plus here. So if you substitute 2, it is my 1 over 3. Oh, sorry, it's a beta distribution. So it must be 2 into, that's a gamma function. This over gamma 3 is a 2 times. It's a 2. It's a 2. It's a 2. Now it's a 4 over. Now it's twice of this. So if you substitute here, you can use calculator, you will get this is the right answer. Okay, look at this another one. It's a 2023. Clearly say they are my independent. This is my normal distribution. The degree of freedom is my 1. Fine. It's a chi-square 1. It's a chi-square 1. But you can see the sum of them will be chi-square 2. So the degree of freedom must be 2, but it is a 1. It's a square. So the numerator will be the chi-square distribution with a 1 degree of freedom. This one is chi-square distribution with a 1 degree of freedom. This one is a chi-square degree 1. So the denominator has chi-square degree 1, chi-square degree 1. That means chi-square degree 2. So it is a 1 degree of freedom. It has a 2. Yes, it's a f square here. E of this one, which of the following is true? Because they are the IID. I can return this quantity as E of x1, E of this number. Fine. So what is the number of this? Expected value of the x1 is 0. So that means this answer is 0. Look at the last option. So I can return this number as here x1 minus x2 and here, which is this one. I consider this number is say my y. Then y will again follow the normal distribution. With this mean is 0, variance is 3. So I can convert into the z. 0 minus 0 by root 3. So what is that? It's a half. But he said 1 over 3. Okay. Again they are the normal distribution. I consider this is my y. 3x2 plus 6x3. So what is my y? What is the normal distribution? The mean is 2. So 4 minus 6 plus 12. So it's a minus 2, it's a 10. Fine. So variance will be 4 plus 9 plus 36 of 4. So 49 into 4. So then my target is to find the y is greater than 17. I convert into the z. 17 minus 10 divided by root of 49 into 4. So what is that? It is 7, 1 over 2. Fine. Now I can return as a 1 minus of this. So it is 1 minus 5 of 1 over 2. So the right answer is 0.5 is the correct answer. You can join my WhatsApp group if you are interested for the IIT JAM groups mathematics and statistics. We will see the next lecture on the univariate distribution. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.